Hello, and welcome to today's Ask a Scientist program. Today, myself and two of my fellow Museum of Science educators will be answering some of the favorite questions we've had about space. My name is Eric, my pronouns are he, him, and I'll let my fellow educators introduce themselves.
Hi, everyone. My name is Emily, and my pronouns are she and her.
Hi, everybody. I'm Talia, and I also use she, her pronouns.
So I'll get started with one of my favorite questions that I've got about astronauts living in space. Does space food taste good? And the answer is as best as we can make it. Space food technology has come a long way since the 1960s when we first started sending astronauts up into space for just a day or two at a time. Now we have astronauts that live on the International Space Station for 6 months or 8 months or up to a year. And in addition to needing a lot of nutrition and to needing a lot of other things from their food, we want to make sure that psychologically they stay on the top of their game. And so having food that tastes good is really important. So we have things like being able to eat a cheeseburger in space. It just looks a lot different than a cheeseburger on the ground. For instance, you have to use a tortilla instead of a roll so that crumbs don't float everywhere in space. But making space food taste as good as we can make it, there's a lot of research and technology that goes into that, and it's a big part, and it's one of the requirements of developing food for astronauts. And we got a follow-up question from Sharon, who's 9, who asked, can you get a pizza in space? Well, you can't get one delivered, but you do get deliveries of food fairly frequently. To resupply the International Space Station, we send up capsules that have fresh food on them and supplies for many months ahead. And the first thing the astronauts always go for is the fresh fruits and vegetables. So you see them going straight for the bananas and the apples and the oranges because those don't last as long. They have to wait another month or two for the next shipment. So they don't send pizza up. They don't really order their own food, but they do get deliveries, and it is as exciting as opening your own door and getting a pizza.
Very cool. Thank you, Eric. So folks, my first question is from Izora, age 9. And I like this question because it's a really big question, and it almost sounds like a scary question too. But it's, what is space? If we're talking about space, what exactly is space? So the best way that I can think to answer that question is to say that space is basically emptiness. There is a lot of empty space that is out there in outer space, but there are some pockets where matter has collected and has attracted together because of the force of gravity. So for example, our planet exists because little pieces of matter collected together, kind of like a snowball, to form our planet. And the same thing happened with the other planets and our sun and all of the stars in our galaxy. But even within our own neighborhood in space, there is a ton of empty space that is out there where there are no particles for the most part. There's no air or things like that. And for example, it took the fastest moving spacecraft 9 years to travel from our planet out to Pluto, which is one of the farther dwarf planets in our solar system. So again, even our small neighborhood in space is huge, and there's a lot of emptiness between us and all of the other things that are around us.
All right, so my first question I chose because it allows me to talk about one of my favorite things. So the question was, what was your favorite space mission? And without a doubt, my favorite space mission was the Cassini mission. Cassini was a spacecraft that launched in 1997. It left Earth in 1997. It traveled for 7 years to get to Saturn. It entered orbit around Saturn in July of 2004. And then it spent the next 13 years exploring Saturn and its moons and its rings and completely revolutionizing what we know about this planet, which is my favorite planet in the solar system. It got wicked up close views of the rings and the fine structure there. It got really close up views of the clouds and of the poles and of all the storm systems we have happening on Saturn. And it got really up close views of the moons. And Saturn's moons are some of the coolest places in the solar system. It has a moon that has geysers shooting an underground ocean out into space. and Cassini actually flew through those geysers. It has a moon that's all dark on one side and all bright on the other side, and Cassini got great pictures of that. And it's got Titan, which is one of the largest moons in the solar system, the only moon to have a thick atmosphere. And Cassini not only got a lot of data on Titan, which told us that it has rain clouds and lakes of liquid methane on the surface, but it actually had a second spacecraft on its back called Huygens. And Huygens landed on Titan. And that was the first time we ever landed a spacecraft on a moon that was not our own. And it was so cool that we're actually designing another mission to go back and take another closer look at Titan. So Cassini lasted for 13 years, and when it ended with the biggest bang ever. It actually spent its last few orbits diving between Saturn and the rings, so between the planet and the rings, and ended by burning up in Saturn's atmosphere, transmitting until the last possible moment every drop of data it could possibly transmit. And it was a very sad day for me when the Cassini mission ended.
Yeah, I love hearing you talking about Cassini, Talia. Our next question that I really like, what's the closest we've ever sent anything to the sun? And that is actually harder than you might think. Throwing something into the sun would be pretty easy, but it would go straight into the sun. The sun's powerful gravity would pull it in, and it would be a pretty quick trip. If we want to go close to the sun with a spacecraft that can actually send us back data and tell us useful things about the sun, we have to get really close to the sun's powerful gravity without having it completely obliterate whatever we send in, and also protect it from the intense heat and radiation from the sun. So the closest we've ever sent anything is just recently with a brand new spacecraft that has broken the record, the Parker Solar Probe. And it has reached 8 million miles away from the sun, which is pretty impressive because the sun itself is about 1 million miles wide. So not that many times further away than the sun is big itself. It's going to keep traveling closer and closer to the sun. Over the next few years, it'll spiral in, and it will end up at its closest only about 4 million miles from the surface of the sun. And it's going to answer lots of questions that we have about the sun that we've had for a long time, including what is going on in the sun's very outer atmosphere, the outer layer that's very thin and diffuse, but is actually much hotter than most of our models predict it should be. We don't really understand why that's the case. So the Parker Solar Probe is going to be flying through this layer, getting direct readings and sending them to us back on the Earth in order to figure out what's going on with this outer layer. So we're going to get a whole lot more information about the sun, studying it up close with really advanced instruments on a mission that's going to keep going, getting closer to the sun and breaking its own record over the next couple years.
Awesome. And that'll be so exciting to keep waiting for all that data to come in and learn everything that we can learn from it. So my next question is not quite a question, but it's something that this person wanted to learn about. They said, tell us about planets in other galaxies, like the Sombrero Galaxy. So the first thing that I'll do is show you a photograph of that Sombrero Galaxy. It's very beautiful. It's called that way because it does look like a sombrero hat. And I wanted to talk about this comment because I think it's pretty common for people to think that we can see the stars and planets that are in other galaxies. But the truth is that we actually cannot see individual stars, and we definitely can't see individual planets because they're even smaller than the stars that we already cannot see in these galaxies. So instead, when we look at other galaxies like the Sombrero or the Andromeda Galaxy, which is a neighbor to us, we look at those galaxies as a whole. We cannot see the individual parts that they are made of. And you might be looking at this photograph and say, well, hey, what about like all of the individual looking stars that are around the galaxy in this picture? But it turns out that those stars are actually stars in our galaxy. And those stars got in the way of us looking at the Sombrero Galaxy and taking this picture. So in the same way that you might look out a window to see the stuff that is outside, while you can see the stuff that is outside, you also see the pane of glass in front of you that your window is made of, or you see the screen, or you see the like the little wooden things that surround the panes of glass. So that's kind of like what these stars are in this photograph. So while it's really exciting to think about other worlds that are extremely far away from us, we cannot see those worlds in other galaxies. Although, with that said, I can't remember, but either Talia or Eric will definitely be talking about exoplanets later on in our program.
I do love talking about exoplanets, but my next question has nothing to do with planets, but it does have to do with the sun. So the question is, it's actually a two-part question. Could the sun turn into a type 1a supernova? And if it does, would it then turn into a black hole or a neutron star? So there's a lot of terms in that that need to be defined. So we think of a supernova. Supernova is a star exploding, right? A big star blowing up at the end of its life. Turns out that's just one kind of supernova. There's another kind, type 1a. And what happens there is a star that was like the sun, which is not going to explode, sort of puffs up and loses its outer layers. And what's left behind is the core of the star, which we now call a white dwarf. That's what's going to happen to the sun in a few billion years. That white dwarf can go supernova in one of two circumstances. If there's another star going around it or another white dwarf. If there's another star, the white dwarf can actually steal material off of the companion star. And as the white dwarf itself gets more and more massive, it will reach a point where it's massive enough that it will collapse and explode and essentially go supernova. The other way that it can happen is for two white dwarfs, so two remains of stars like the sun, to actually collide and merge, and then they're massive enough together that they explode. And that is also a type 1a supernova. So the answer to the first part of the question, could the sun turn into a type 1a supernova, is no, because both scenarios require a companion, a second star, either a second living star or a second star remnant. And the sun has no companion stars. The sun is by itself in space. A lot of stars out there are not. A lot of stars have companions, which is why you get type 1a supernova, but not our sun. Now, for the second part of the question, if it could, when say a type 1a supernova does happen, does the remains, is there a black hole or a neutron star left behind? These are the things that get left behind when a massive star blows up. The core of the star collapses down and forms either a neutron star or, for the very biggest stars, a black hole. So that's the leftover core, remnants of the core of a really, really massive star. With a type 1a supernova, usually there isn't anything left. The white dwarf was pretty small to begin with, and when it explodes, there's just kind of not anything left, usually. I did read a paper recently that suggested that when the scenario is two white dwarfs merging, you might, in some circumstances, get a small neutron star left behind, but that was still a theory, hadn't been proven. So generally the answer is no. When a type 1a supernova happens, there's just nothing left. So it's not going to happen to our sun, and even if it did, there wouldn't be a black hole or a neutron star left behind. There would be nothing. On that note, Eric, do you have anything that doesn't involve total eradication?
I mean, it's interesting to think about, and we definitely see it in the universe, but I do have a question next about the way our solar system is set up. And the question is, why do all the planets orbit in the same plane? And that is true. If you take a look at the solar system and the planets, they all orbit around the sun. Those orbits are close to being circles. They're not quite exact circles. They're slightly squishier. They're called ellipses. Some of them are more close to a circle. Some of them are more close to real true oval. But they all align in pretty much the same plane. If you looked at the solar system from above, you would see all 8 planets going around in nice overlapping ellipses. And if you look from the side, it would be perfectly flat like a pancake. So why don't they just orbit in every which direction? It has to do with when the solar system first formed. It started out as a big cloud of gas and dust with no stars and no planets formed. And then something happened to that big cloud. Maybe a supernova nearby exploded and caused a shockwave to move through all that gas and dust, and little pockets started to clump together because of gravity. And then those pockets started to clump together with other pockets, and eventually the sun started to form from the biggest of those pockets. And as it grew in size, its gravity increased in strength, and it was able to draw more material in. And then almost all of that material went into the sun at the center, but some smaller pockets on the outside of that cloud formed the planets. Now, the reason that this happened and led to our planets being in the same plane is because the tiny little amount of spin that that cloud had at the very beginning would be amplified by its contraction. Similar to how you see a figure skater spinning around with their arms out. As soon as they bring their arms in, they start to spin faster. As this big gas cloud contracted into smaller objects, the spin was much more enhanced. And also, what you get when you have a 3D cloud collapsing into a smaller object, it first forms a disk. This is just the way that physics works. If you have a cloud collapsing in on itself, it forms first a disk of material, and then out of that disk of gas and dust, the planets all started to form from the bigger clumps. So the disk turns into a bunch of planets, and all the rest of the material gets cleared out once the sun really turns on and starts blasting off heat and radiation and particles. And what we end up with is the sun and all of those nice planets in their orbits in the same plane. And that doesn't mean there aren't objects orbiting in different planes, but the planets, those biggest part of the remainder of that gas and dust, they all orbit in that nice even plane, making the solar system kind of appear to be almost pancake shaped.
Very cool. Thank you, Eric. Now, my next question is from Kyra, age 11. And they say, since a star's light takes so long to reach us, how do we know that the star is still there? So this question is kind of related to Talia's talk of stars exploding. So the first thing that I'll say is that stars explode, that is true. Or even if a star isn't big enough to explode, it does sometimes kind of go out and die, and it stops making energy. So it is possible for a star to dim and disappear in some way. So the short answer to the question about how do we even know that the stars in our sky are still there is that we don't actually know, because it's true that these stars are so incredibly far away from us that it takes a lot of time for their light to travel through space and reach our eyes. So an example of this is Betelgeuse. Betelgeuse is a red star. It's a red giant star. It's one of the biggest stars that we can see in our nighttime sky, and it's in the Orion constellation. So you'll be able to see it later on this winter. And Betelgeuse is over 400 light years away from us, which means it takes 400 years for the light from that star to travel through space and reach our eyes. So if you were to go outside tonight and try to look for it, you would see Betelgeuse as it appeared 400 years ago. So even if that star exploded today, we would not see that explosion in our sky until 400 years later. The flip side of that is that if Betelgeuse exploded 400 years ago, then we would see that explosion today, or at least in the near future. So again, we really just don't know when these stars will explode or when they will go out. We can make very educated guesses, though, by studying these stars and understanding more about them. So for example, if we see like a middle-aged yellow star in our sky, we can probably say that it's not going anywhere anytime soon. But if we see a really old red star that just really looks like it's about to die or blow up or whatever the case may be, then we can at least try to guess when that might happen. And it's usually in the range of millions of years. because even that amount of time is a short amount of time compared to a star's life. But it's so far the best that we can do.
All right, Emily promised you we would talk about exoplanets, so let's talk about exoplanets. We had a question come in. We get this question a lot. I'm gonna specifically call out this one from Clement, who is 8 years old, who asked us back in the day, how many exoplanets are in the universe? Short answer, we don't know. An exoplanet is a planet outside our solar system, so a planet that's not orbiting the sun. And the short answer is we don't know how many there are. But long answer. We keep finding more and more and more in our own galaxy. As Emily said, we can't really see them outside our galaxy. But we have found something over 4,000 confirmed exoplanets within our own solar system, with another several thousand that we think are there but have not yet confirmed. The frequency with which we find them makes us think that there are probably as many planets as there are stars, at least in our galaxy. And so we can probably assume something similar for other galaxies as well. So if there are as many planets in our Milky Way galaxy as there are stars, that means the Milky Way contains somewhere around 300 billion exoplanets. And that's just the Milky Way. We think there are about 2 trillion galaxies in our visible universe, some of which are bigger than the Milky Way, some of which are smaller. So they may have anywhere from a few thousand to a few trillion stars, which probably means they also have a few thousand to a few trillion planets each. So multiply that by the 2 trillion galaxies we think are in the visible universe, and no, I'm not doing that math. A lot is the answer. We think there are a very, 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 very lot of exoplanets in the universe. We don't have an exact number though.
That's related to the next question that I wanted to answer, which was very simply, are there aliens? So is there life on other planets in the universe? Is there alien life within our solar system? Well, we've looked on Mars and we don't think there's any life there now. If there is, maybe it's tiny little bacteria living way under the soil. We'd like to look for it. There might be some life in places like Europa, a moon of Jupiter that has a deep undersea ocean. We'd like to look there someday. But I'd like to think of this question kind of at the big picture. Is there intelligent life out there in the universe? And a big question that goes along with that is called the Fermi paradox, which is, if there's intelligent life out there, where is it? Why haven't we seen evidence of it? Why don't we see radio signals beaming around the universe that we can pick up with our telescopes if that's what we're doing with our technology? Why haven't we seen aliens who are so advanced that they can zip around the universe faster than the speed of light, or use wormholes and use technology that right now is our science fiction? Where is everyone? So there's a couple different ideas for the answer of that. Maybe there are intelligent civilizations out there, but they keep civilizations like ours that are just getting to space separate and make them, kind of prove themselves, or maybe they wait till a certain point to introduce us to like the galactic order. Or maybe it's the case that civilizations aren't sustainable and either they exhaust their resources, or war or disease or something else causes them to die off before they can truly become galactic faring civilizations. Or maybe we're just the first ones. Maybe it takes a universe 14 billion years, all that time until from the Big Bang until now, for there to be enough elements built up and the building blocks of life to be able to have intelligent life develop in just the right conditions. Maybe Earth was just the first time that happened in the entire universe. So there's a really great quote by sci-fi author Arthur C. Clarke in regards to, is there intelligent life out there in the universe? Either there is or there isn't. And both possibilities are terrifying.
Wow.
Yeah, I like that. That really sits with you. We should have ended the webinar with that. I like that.
Oh, well.
Well,
Okay.
looks like we've got time for one more quick question from each of us.
Okay, so my next question will bring us a little bit closer to home. I want to talk about the largest volcano in space. And this question was asked by Clement, age 9, who, by the way, I noticed has aged a year since they've been
Yeah, he was
asking
only
us questions.
when he asked about
So
exoplanets.
cool. Yeah, so just a fun fact to throw in there. So let me share my screen because I do have some photos prepared for this one. It turns out that the biggest volcano in space belongs in, let's see, oh, barnacles, there we go. It's on the planet Mars. So here's a quick graphic of Mars. Mars is the red planet in our solar system, and it actually looks red in our sky, and it's very visible tonight and for the rest of the winter. And the biggest volcano in our solar system is Olympus Mons. And I'm never truly crazy about the photographs of this volcano because it always just looks like a giant pimple to me, but it is extremely, extremely impressive. This thing is as tall as 2.5 Mount Everests, and Mount Everest is the tallest mountain on our planet. But I also wanted to mention Io, which is a moon that is orbiting around Jupiter. Io, it's also covered in volcanoes, kind of like Mars, and these volcanoes on Io are actively erupting. These two images are both of the same moon, but on the one on the left, you can see just how huge that plume is and how much it's sticking up off of the surface of that moon. And then in the other image to the right, you can see that there are 3 eruptions happening all at the same time. And Io does have some volcanoes on it that are bigger than Olympus Mons in surface area, but they're not as tall. So that's why Olympus Mons gets the tallest or the largest volcano in the solar system award.
So I have a great question here that it might be a great question for us to end on because I think all 3 of us ought to answer this one. The question comes from Faith, who was 9 years old when the question was asked. Who knows how old now? The question is, would you go into space? And if so, where would you want to go? So I'll start. The answer is I would absolutely go into space, assuming that I felt there was a reasonable chance of me getting home. Space is never going to be completely safe, so your odds of getting home are never going to be 100%. But if I felt there was a pretty good chance that I would be able to get back to Earth, I would absolutely, in a heartbeat, go into space. Just show me where to sign my name, and I will be on the next rocket available. As to where I would like to go, I mean, the short answer is everywhere. Let's assume that I don't have to worry about the really, really long, let's assume we've solved interplanetary space travel, which at the moment we haven't. But if I could go anywhere, I mean, I'd start at the moon. Like, that would be the first jaunt. Go check out the moon.
That would be like a weekend trip.
Like a weekend trip to the moon. Yeah, absolutely. And that can be like the starting point before I go to Mars. And go, spend some time on Mars. But really the place I'd really love to go, I've already told you it's my favorite planet. I would love to see Saturn in person. Saturn, visit some of its moons. Oh my goodness, that would be the most amazing thing ever, to get to see Saturn up close with my own eyes. I've seen it through a telescope. It's amazing through a telescope from here on Earth. But to be able to see it up close, and I've seen it through Cassini pictures, and it's amazing, but to be able to see it up close with my own eyes would be unreal. Just takes 7 years to get out there. That's fine. That's not a problem, right? Mm-hmm.
So for me, I do not have a desire to travel into space. I'm kind of a chicken. I don't even like the thought of scuba diving terrifies me too, just because there's that danger of like suffocating or drowning. I'm not into it. But where I would try to go is, some kind of planet with a couple of suns in the sky. I would try to have a nice sci-fi Star Wars moment, or maybe somewhere that had multiple moons that were nice and big, kind of like our moon, but multiple. I would just want to see a really beautiful, like, sky moment from wherever I go.
I have to say, it's funny, Emily, that you said, scuba diving freaks you out, because the ocean freaks me out.
Yeah.
The ocean makes me very, very nervous. I'd go
There's
into space
something
in a
we haven't
heartbeat.
discovered yet down there.
I'd go into space in a heartbeat. The ocean makes me very, very nervous.
I think I would go to space if I got the opportunity, just because it's awesome enough to be worth it. I hate flying and I get sick on roller coasters, so I don't think I'd do very well, but I think it would be worth it to go to space. And I think I'd do a little bit of a Talia, pit stop on my way to my destination. I'd love to visit the International Space Station and see the research going on there and be able to look back down at the Earth to really get the sense of our planet. And then I'd like to go all the way out to Pluto. Honestly, the nitrogen glaciers, the mountains made of ice the size of the Rocky Mountains, and the sun being in the sky just looking kind of like a bright star because it's so far away, seems like a nice quiet place to spend some time in the solar system on a vacation. Well, that's all the time we have for today's program. I'd like to thank all of you for tuning in. If you have questions that you'd like us to see answered in the future, you can send them to us at sciencequestions@mos.org. And we might feature them on our podcast, Pulsar, that answers the most intriguing questions that we've ever been asked at the Museum of Science. We've got lots of other programs on MOS at Home, so check our website for that. But that's all we have for today. Enjoy the rest of your day, everyone. And until next time, keep asking questions.